Okay, we're going to go on to the next section, the next worksheet, which is chapter 612, worksheet 2. Same things that we did in section 6.1 and the first worksheet over here. So let's go ahead and start directly in with the homework. Now, remember whenever I did this section, I talked about a piggy bank problem. Since those are all attached by multiplication, this is a piggy bank problem, and you're simply rearranging. So I'm going to have 18 times 3 to the negative 3, x to the negative 18 times x to the negative 1, and y to the 7th times y to the 5th. That is a rearranging problem. So go ahead and say, should I stay or should I go? The 18 has a positive exponent, the 3 has a negative, so it goes to the bottom and becomes positive. We are going to add these exponents, making sure you know those are all in the numerator. So that's 18, x to the negative 9th, y to the 12th, all over 3 times 3 is 9 times 3 is 27. We're going to reduce those and divide them both by 9. If we divide those both by 9, I'm going to be left with 2 over 3. The x is negative, so it goes to the bottom, and then the y to the 12th stays on top, and you are done with that problem. Okay? Next, number 2. Same exact concept. Do I have any exponents on the outside? The answer is yes. I have a 2 that needs to have an exponent on it, a 7 that needs to have an exponent on it, because this has an exponent of negative 2, and that needs to go to each term. Those already have exponents on them, but look right here, folks. This right here is to the power of 0. When it's to the power of 0, the entire thing goes away and turns out to be a 1. Okay? So we're going to go ahead and ignore that because it's no longer needed in the problem, and we are going to distribute this. So that's 2 to the negative 2 over 7 to the negative 2, x to the 12th, y to the 16th, extending that bar, times, this goes x to the negative 6, y to the negative 9, extending that bar. So 2 to the negative 2 goes to the bottom and becomes 2 squared. 7 to the negative 2 goes to the top and becomes 7 squared. Then I'm going to add my x's together, and I'm going to add my y's together, extending that bar. 7 squared is 49. 2 squared is 4. We're going to go ahead and add these x's together to give you x to the 6th, y to the 7th. And all of them have positive exponents, so you are done. Okay? Next, number 8. Number 8, we're going to put on a power of 1 here. The only thing that goes in with this power of 5 is only the numerator. The denominator does not get touched at this moment. So that's going to be 2 to the 10th. No, sorry. Was not looking. 2 to the 5th, r to the 25th, s to the negative 40, all over 6 r to the negative 7, s to the negative 10. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have 32 r to the 25th, s to the negative 40, over 6 r to the negative 7th, s to the negative 10. 32 over 6 is going to divide them both by 2, and that's going to give you 16 over 3. We're going to subtract these exponents, r to the 25th minus negative 7, negative 40 minus a negative 10. A double negative creates a positive in both of these. So I have 16 over 3, r to the 32, s to the negative 30. Extend that. Should I stay or should I go? The 16 stays, the r to the 32 stays, the 3 stays, but the s to the negative 30 goes to the bottom, making that positive. Okay? Next, the directions say simplify and find all the real number roots. Real number roots. So this right here is going to be the 4th root of 81. This is going to be 1, 2, 3, 4. So 81 over the 10,000th position. I have the 4th root of 81, the 4th root of 10,000. So the 4th root of 81, take the square root of 81, which gives you 9, and then take the square root of 9, which gives you 3. Okay? 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. And sometimes I need to write that out for everybody to understand that 10 to the 4th is 10,000 to give me a 10. And that is just going to be 3/10. Okay? Go ahead, number 15. Same concept. Now, I do need to read the directions on 15 to see exactly if I have to assume all variables are positive or not. So this says, simplify and find all the real roots of each radical. It does not say to assume any of them are positive. So absolute values may happen here. So if I go ahead and do that, I'm going to marry the outside, 2 times 3, which gives you a 6. The square root of 27 times 39. A to the 6th, B to the 3rd. Okay? Now I didn't do 27 times 39 because I don't know what that is off the top of my head. So what I'm going to do is I'm going to break this down into perfect squares. This is 9 times 3. 39 is going to be 3 times 13. A to the 6th, 6 is divisible by my root, but B cubed is not. So that's going to become B squared times B, because my power of 3 is not divisible by my index of 2, so I break it down. So this is going to give me 9 times 9 times 13, A to the 6th, B squared times B. Square root of 9 is 3. Square root of 9 is 3. 13 stays. Square root of A to the 6th is A to the cubed. Square root of B squared is B, and then B stays on the inside. 3 times 3 is 9 times 6 is 54. A cubed B times the square root of 13B. Now remember, I did not say to assume that all variables were positive. So therefore, do I have any even roots? I do have an even root, and I do have odd powers. So absolute value bars go around only the A and the B to ensure that they stay positive. Number 18. What do the directions say on those? Same exact concept. So I'm going to tear these apart. Now, currently I have an X in the 3 X's in the denominator. I need to have an even number of X's down there. I only have one 10 in the denominator, so I need to have another 10 and I need another X to make them both have even powers. So I'm going to multiply both of these by 10X. This is going to give me, this comes out as a 3. Three times the square root of 10x all over 10 squared x to the 4th. And now we're going to keep on going with that. So that's 3 times the square root of 10x. The 10 comes out, and the x to the 4th comes out as an x squared, so that's 10x squared. Done. Now, I do not need to have absolute value bars because this is an even root with an even power, so I'm okay. Number 20, let's see what the directions say for number 20. Still all the same instructions, so therefore I'm going to go ahead, I have an even root. So 2,401, so I'm going to come over here and say, can I take the 4th root of that? 2401. I don't know. I can. It's a 7. So I can do this. So I leave that number alone. 12 is divisible by 4, so I leave that alone. 7 is not divisible by 4, so I'm going to break that down. So if I have to be divisible by 4, I'm going to have t to the 4th with 3 t's left over. Because if I just go 6 and 1, 6 is still not divisible by 4. So I have to do by powers of 4 because that's what my index is. So whenever I do this, the 4th root of 2,401 is 7. The 4th root of s to the 12th, 12 divided by 4 is 3. This comes out as a t, so I have 7s cubed t times the 4th root of t cubed. Now, did I take the even root? I did take an even root, and and I do have odd powers there, which means I need to have absolute value bars around my s cubed and my t. And then that is done. Last problem. Well, I look at this and I see that we've separated them, and I know that 96 is divisible by 3, and I know that x to the 9th is divisible by x squared. So I'm going to go ahead and put these back together, making this the 5th root of 96x to the 9th over 3x squared. 96 divided by 3 is going to be 32. I have 9 x's on top and 2 on the bottom to give me x to the 7th. So now I'm going to go ahead and break this down. 32 is a perfect fifth, but my power of 7 is not divisible by my root of 5. So I have to make that x to the 5th with 2 remaining x's left. The 5th root of 32 is going to be 2. The 5th root of x to the 5th is x, to give me 2x times the 5th root of x squared. Do I need absolute value bars? Did I take an even root? Is my index even? My index is not even, so therefore I do not have to worry, and my problem is done. That is 612 worksheet 2. If you have any questions, please let me know.